All right, here we go, part two. So you said you understood part A, conservation of energy, solving for V. So we have this. So we're moving on to part B. And this is where it gets a little complex. But it's only if you're seeing the geometry that it becomes simple. But just setting up the problem is kind of hard. So here we go. I went ahead and called this H1, this length right here, D, and this is the length of the board, L. Still the 45-degree angle. So sine of 45 is 1 over root 2, or some people in trig just say root 2 over 2 when they rationalize, but it's still the same thing, 0.707. Cosine is the same. So what you see is that sine is equal to h1 over L. Opposite over that, cosine is adjacent. So we set those equal to here, and then we solve for D and we solve for H, and we see that they're same. Or you could just look at this geometrically and be like, oh, D and H are the same. Some of my really bright kids, like, they noticed that immediately, and they're like, oh, since D was equal to H1, and this is because it's a 45-45-90 triangle, I can set, when I'm solving for the time, that D is equal to velocity times time, and H1 equals to 1/2 gt squared. And they just went right into the step without doing this crap right here. So that's the stuff that they did. And then it just becomes a straightforward projectile motion problem where you take off the board. And so you know that this right here is the same as this right here. And so when you solve, you cancel out 1t. You get t, you end up solving, you get 2v over g. But we've already solved for v in part A. So I'm just going to plug that in. So this is the answer, and this answer suffice, and I think it's actually one of the answers that's given. But to get to the answer that they have, this answer would have been fine. You can write it all as a radical, so that's what I did here. 2 equals square root of 4, g equals the square root of g squared. I put it all underneath the radical sign. I did some eliminating. I end up getting t. Please feel free to pause it if I'm going too fast. All right, and then C. So part C, then we just take one of our equations that we had right here. So D equals L over root 2, or H equals L over root 2. I did D because it's a more simple equation, VT. So I wrote that like this. So I'm going to set the L equals root 2D. I solve for this one. I'm solving for L, that's my goal, equals velocity times time. I have a velocity equation and a time equation now. So I plug this all in. I get 2 times 2 times 8 times h squared, which is the root 32 h squared, which is 4h root 2. That's what L equals. So this is the length right there. Now going down to D, conservation of energy. So instead of starting at the initial height of just mgh, it goes that additional length. It goes that mgh here until it hits the ramp, and then it goes an additional height here, this h1. And we know what h1 was. It was L over root 2. That's what they said. But I mean, you could plug it. There's a bunch of different ways of doing it, but I'm just going to take their approach. So mgh plus this additional height has to be equal to 1/2 mv squared. Because all we care about here is the energy, because we're calling this height 0, h equals 0. So all of this is going to be converted into velocity at that point. So with a little bit of algebra, and I even messed up because algebra is complex, we have mgh. I lose one of the m's. I went ahead and took care of that in the beginning. Gh equals g times this, which we found here. We plug that in here, and so we get 4h. I think you can see the work, 4h root 2 over root 2. And so from that root 2 and then this root 2, they cancel. Then I have 5gh, 1/2, and I call it v2 squared because the horizontal velocity was just v. So v2 squared, and we're going to multiply both sides by 2, and then you end up getting that as the final velocity. I hope that helps. This was really difficult. If you want the lab that I did with this and then gave them this problem, they were really good at it after we went through this as a lab. And I thought it was really good for them to see the stakes of what the course was after the energy unit. But anyway, talk to you later. Bye.